Hey guys, Tech Teach again, and in the last lesson we learned how to calculate the gear ratio of a gear train of two gears here by counting the number of teeth on the gear. So we figured that if this is the drive gear, then this is the driven gear. This is in and this is out. Well, let's take a problem here, and let's say uh, if we have two gears and we know that this gear is 2 inches, then we also know that this gear is 1.33 inches. Then, how do we calculate the gear ratio of these two gears? Well, you use the formula GR over 1 equals D out divided by D in. So if you take those gears and you look at them as 1.33 is the D of in, that's right here, it goes there. And you look at the 2-inch diameter gear, and that goes right here as D of out. So you cross multiply these. You say GR times 1.33 inches, and you say 1 times 2 inches. So that'll look something like this. You're saying GR times 1.33 inches equals, forgot my equal sign there on our equation. Let me move it up. See, the equal sign goes right here. Now you say 1 times 2 inches. So, and it's not always 1. It's not always a 1 on the bottom. Sometimes you get a different number. So if you do it out this way every time, you'll do a better job. So we divide both sides of the equation now by 1.33 inches. It's always the number that is next to the variable. GR is the one that is the unknown. That's our variable. So we divide 1.33 inches here by 1.33 inches there. You factor those out. Now what is 1 times 2 inches is 2 inches. So what's 2 divided by 1.33? This is the answer I got. It was 1.5037 blah 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 blah. This will factor out or round down to 1.5. So basically we've got the same thing. So we can say now clearly we've just proven that the gear ratio over 1 is equal to the number of teeth out over the number of teeth in, and is also equal to the diameter of the gear out divided by the diameter of the gear in. In the next part of the equation, you can also factor the speed at which the wheel or the gears are turning, or the speed at which the gears will turn. The W here is the omega, the Greek letter omega. But this, if you look, in out, D out, omega in. So now we're looking at an inverse in the speed at which a gear turns. So the speed of the gear is in the A position on top, and the speed of the gear in the B position at the bottom. Okay, to figure out how fast a gear is turning, we talk in terms of revolutions per minute. So let's say that gear A is turning at 30 revolutions per minute. Then how fast will gear B turn? Let's make some visual clues here. The work in is at the top, the work out is at the bottom. The speed at which this smaller gear is going to turn is going to be faster than the speed at which the bigger gear is going to turn. Revolutions per minute. So every time this one turns, this one is going to turn 1.5 or this one's going to turn 1.5 times for every one turn of this gear. So this one's going to go a little slower than that one. So if we say that 1.5 is the, I'm sorry, not 1.5. If we say that 30 is the speed at which the in gear is turning, then how fast is the gear that is being turned going? So we need to know some information because we can't have two unknowns. Well, we knew last time that the gear ratio was 1.5.